Okay, hello. Here is a question from the TMUA set of papers. This is 2017, paper 1, and we're looking at question 10. What have we got here? We've got a curve, C, that has got equation y equals f of x, where f of x is a polynomial, and it happens to be a cubic, and annoyingly, it's written with the cube part at the end. And we're given that p is a real number, so p is part of the coefficients. The gradient of the normal to the curve to the curve C at the point where x is minus 1 is m. So it's got some gradient m when x is minus 1. It talks about the gradient of the curve. So not gradient of the normal to the curve, I should say. That's going to be important. Normal. What is the greatest possible value of m as p varies? So we want the steepest normal that's possible, depending on what p is. So we're talking about the normal. So the first thing we seems sensible is to differentiate to get the gradient of the curve at any point. So let's do that. F prime of x equals, and I'm going to start at this end and work that way to get them in sensible order. So minus 3x squared, and then plus 2 times 3 is 6px, minus 6p squared. So that is the gradient at any point on the curve C. But specifically, we want the gradient when x is minus 1. So let's substitute that in. F a prime of minus 1. So minus 1 squared is 1. So that's minus 3 plus, wait a minute, minus, so that's minus 6p, substituting in minus 1, and minus 6p squared. So that's substituting in, we get that expression for f prime of minus 1. So our expression for m will be this in terms of p, but this is the gradient of the tangent at the point minus 1. We want the normal, so it's the reciprocal, the negative reciprocal, so we can rewrite it as this: 6p squared plus 6p plus 3. And we want this to be as big as possible. Well, we've got a quadratic in p here, and also I noticed that the everything's a multiple of 3. So having said that, I'm not concerned about that. I'm thinking about if we're looking for a maximum or a minimum or some sort of turning point, it looks like a good idea to complete the square here. So let's complete the square. Let's take out the 6 out of the first two terms. So 6 brackets p squared plus p plus 3. And then let's complete the square inside the brackets. So we've got p plus a half squared minus a quarter plus 3 equals 1 over, let's expand the bracket, the square bracket, 6p plus a half squared minus 6 over 4, minus 6 over 4, 6 over 4 is 3 over 2, 3 over 2 plus 3 equals, and simplify the constant part, 6 p plus a half squared minus plus 3 halves, 6 halves minus 3 halves is 3 halves, 3 over 2. Okay, so this is m, and we want the maximum value of m max, depending on what p is. Well, to make this as big as possible, we need to make the denominator as small as possible. Well, when's it as small as possible? It's when this part is 0. So that happens to be when p is minus a half, but we don't want p, we just want m max. So this part is 0, so it becomes 1 over 3 over 2, which is just 2 over 3. Isn't that in the list of answers? And yes, it is. It's here. It's E. So that's our answer.